Let's have a look at optical cabling. Nowadays, fiber optic cabling forms the backbone of many of our networks. Fiber optic cable uses light pulses which are significantly faster than copper cables. New fiber lines are being installed everywhere, and fiber is the preferred communication media for long-distance communication all over the world. Fiber optic cable uses strands of glass or plastic to transmit data as light. Depending on the cable, there may be one or multiple strands inside the cable. For the average IT technician, the fiber you will be working with, if you get to work with fiber, will most likely just have one strand inside the cable. Multiple strand fiber cable is often used for long-distance communication by telecommunication companies. In this example, I am utilizing a line tester to send a laser through a fiber optic cable to test its functionality. As you can observe, the light successfully travels through the cable. It is important to note that in typical network applications, the light used is invisible to the naked eye, but can pose a hazard to human eyesight. The cable has an outer sheath to protect the strands inside. The strands can be anywhere from 8 to 50 microns wide, so they are very thin and very fragile. When working with fiber cables, do not bend the fiber cable, as doing so will break the core inside. Also, when storing the cable, it needs to be rolled up. When you purchase them, they should be rolled like this one. If they are not rolled up correctly, I would not buy them. In the majority of networking scenarios, it's common to enlist a professional cabler for the installation of fiber cables. These experts ensure that the cabling is installed correctly, adhering to crucial guidelines like not exceeding the bend radius. Fiber termination panels are designed with additional space to safely coil the excess cable, maintaining the integrity of the bends. On a personal note, I approach fiber optic cable with utmost care, treating it as delicately as one would handle something as sensitive as kryptonite. It is important to resist the urge to casually handle or tamper with fiber cables, as doing so can lead to breakage and repairs can be costly. Fiber optic cables have a major advantage over traditional metal cables. They are immune to electromagnetic interference because they are not magnetic. This characteristic is important in environments where electromagnetic interference can be a major concern, such as near industrial machinery or high-voltage power lines, and in hospitals with sensitive medical equipment. No additional electromagnetic interference shielding is required. Fiber optic cables are harder to compromise than copper cabling, but it is not impossible. In the past, cutting fiber optic cables cleanly necessitated the use of a microscope, but modern advancements have introduced specialized equipment to simplify the process. Despite these technological improvements, a certain level of technical skill is still required to execute the task successfully. To safeguard against unauthorized access, most companies will implement robust authentication and encryption protocols for their networks. This should be considered the primary defense against unauthorized data access. Nowadays, there are numerous methods for hardware-level authentication, ensuring that only authorized devices can access the network. Once a device is verified, the data can easily be encrypted. Thus, cable security becomes less important, as if a hacker gets access to a network cable, they won't be able to decrypt the data. Some organizations adopt the strategy of using visible cabling as a security measure. The rationale behind this approach is straightforward. If the cables are in plain sight, it's easier to detect if any unauthorized listening devices have been attached. Usually, companies who use this method will use transparent conduits to keep the cables visible. However, it's almost inevitable that there will be sections of the cable that remain out of sight. To my knowledge, there is no formal standard mandating this practice, but it's more commonly observed in government facilities when it is used. In my view, while visible cabling can offer a sense of security, the most effective way to ensure the safety of your network is through robust encryption. This method provides a higher level of security against potential eavesdropping or data breaches. Nonetheless, the visibility of cables can still offer a degree of reassurance for some, serving as a physical confirmation of the network's integrity. There are two main types of fiber cables. These are single-mode and multi-mode. The cables will look the same, so you need to read the printing on the cable to determine which is which. Single-mode fiber has a core width of 8 to 10 microns, whereas a multi-mode fiber is 50 to 62.5 microns in width. The narrower core of single-mode fiber limits the light to a more direct path, reducing the amount of light bouncing or reflection within the fiber. This streamlined path is why it's called single-mode, as the light effectively travels in a more singular path. On the other hand, the broader core of multi-mode fiber allows light to reflect and bounce at various angles. This variance in angles causes the light to travel at slightly different angles and arrive at the destination at slightly different times, creating multiple paths or modes of light. Hence it's termed multi-mode to reflect the multiple paths the light can take within the fiber. Single-mode fiber is capable of transmitting data over longer distances and supporting higher bandwidths. Consequently, it is used by telecommunication companies for their long-haul lines. These lines can extend for miles using a single cable, with the distance and performance varying based on the cable's quality and the bandwidth utilized. However, the manufacturing of single-mode fiber with its thinner core is harder and thus comes at a higher cost. There are different standards for each cable. It's not something that is mentioned in the CompTIA study guide, so you don't need to know it. I mention it because if you are purchasing cables and you buy one of a higher standard, it will allow you to run longer distances and support higher bandwidths. It does, however, cost more. Multi-mode fiber is for a shorter length and supports less bandwidth. Despite being relatively short in length, the performance of the cable varies with its quality, allowing it to cover distances ranging from 100 meters to a kilometer. Additionally, it can facilitate data speeds of 1 gigabit per second or more, depending on the specifications. Multi-mode also costs less than single-mode. Single-mode will always be used for long-haul lines. However, it can be used inside your server room or to connect your devices in your office. Devices that don't require one or the other can use both. The difference comes down to how far you want your cables to run and the maximum speed you can achieve using them. Multi-mode cable with its wider core can generally bend more than single-mode and is a little less fragile. Both single-mode and multi-mode fiber cables are used in server rooms and to connect devices together. Ultimately, the decision between using single-mode or multi-mode hinges on the unique requirements and circumstances of your setup, balancing factors like distance, data rate demands, future-proofing, and budget considerations. Now that we've had a look at the cables, let's have a look at the common connections used with fiber cables. The first connector I will look at is the straight tip or ST connector. This connector features a bayonet-style design, which requires a push and twist action to connect the cable securely. To effectively use this connector, you need to insert the cable and then twist it. The goal is to align the small protruding metal piece of the connector with the recessed area. You can see I've lined them up so the protruding metal is inside the recessed area. I next need to push the connector in, turn it so it locks, and then release the connector. If you have trouble getting the connector to go in, it is probably because the protruding edge is not lined up with the recessed area, so twist the cable around until it does. The main thing with this connector is to remember the abbreviation ST. For this connector, I use the memory jogger stick and twist. The ST connector was a staple connector in early telecommunications infrastructure and is still present in older telephone networks. While historically significant, it is now largely outdated and rarely used for new installations. When used, it is generally for multi-mode networks, so you will most likely find it in older buildings and older data centers. You generally don't find it used in long-distance lines. The subscriber connector, or SC connector, features a user-friendly push-pull design for easy and secure cable connections. It is much easier to insert and remove than ST. Generally, this connector will be used over ST for new installations. It is used for both single-mode and multi-mode cables, but is not used for long distances. So, you may find it used to connect different parts of your building or campus networks together, assuming the site is not too big, but for longer distances it won't be used. For example, connecting two different sites together. In this demonstration, I will connect two fiber optic Ethernet converters together using an SC cable. Although most of the time you need a pair of fiber cables to transmit and receive, this converter uses a single cable to transmit in both directions. You can see the cable has a square end with a protrusion top and bottom to prevent the cable going in sideways. The cable has a cap on the end. Any new cables always have this to protect the cable. It needs to be removed before I insert the connector into the fiber converter. To install, just insert the connector into the fiber optic plug. This is much easier than the ST connector, and you can see why it is replacing the ST connector. The connector comes in single and double versions. In our demonstration, we only need the one, but if you are connecting to a device like a switch, it will most likely use two fiber connectors. Using two cables allows for more speed compared to using a single fiber cable. If you have trouble remembering the cable, I use the memory jogger Stick and Click. For the A+ exam, remembering SC should be enough. You are unlikely to need to know it is called a subscriber connector. The next connector I will look at is the Lucent connector, commonly referred to as the LC connector. This is a small form factor push-pull design connector with a locking tab. All you need to do is push it in and it will lock in place. The LC connector comes in both single and dual configurations. However, the dual connector variant tends to be more prevalent with patch cables. The LC connector is commonly used in network devices and long-haul lines. Since the connector is smaller than the others, it works well in devices like network switches. With these devices, there is often not enough room for the larger connectors. The LC connector is used for both single-mode and multi-mode connectors. It works for longer distances than the SC connector, but does cost more. So generally nowadays, you will see the SC connector or LC connector. The LC connector is becoming more popular, but due to its higher cost, you will still see the SC type being used. You can see here a typical LC connector. Notice that it is a dual connector, which is common for patch cables. I will first pull out the protective caps from the cable. With fiber cables, if you ever unplug them, put the protective caps back on. The ends are precisely polished ceramic tips that align and connect the optic fibers. Any damage or dust on the end of the connector can affect the performance of the cable. To install, push the cable into the plug. It will only go in one way, so if it does not go in, flip the cable and try again. Some plugs will also have a latch to help hold the cable in place. You can see how easy it is to plug these cables in and how small they are, which is why they are becoming more commonplace. To remember the LC connector, I use the memory jogger little connector. LC is the smallest out of all the connectors. For the exam, if you can remember the abbreviations for the connections, that should be enough. Fiber optic cables can use different connector types. In this example, a fiber patch cable is used to connect an ST to an SC connector. The connector you use won't make a difference unless you are using very high-speed connections. If this is the case, all your cables will most likely be SC or LC, with LC connectors becoming the more commonly used. For the A+ exam, be able to at least recognize that the abbreviations ST, SC, and LC are used for fiber connections. You may get a question that only uses the abbreviations, and you will be expected to know it is for a fiber connection. It is unlikely that the exam will delve deeply into connections, since the A+ exam only covers basic networking. So what did the single-mode fiber say to the multi-mode fiber after a long day? You must be exhausted. I only had to travel one path, but you had to bounce around all day. And thanks for watching.